Newton's first law of motion gives a simple definition about force. It gives just a definition of force. Already we know the definition of force, that is, it is nothing but a push or pull. But how the definition says means, an object will remain in its state of rest. An object will remain in its state of rest. First is state of rest. Or an object will remain in its state of motion. Can you understand? The star is at rest. It will remain at rest. This case, if a vehicle is moving, it will remain in the state of motion till, that is, unless it is compelled by an external unbalanced force. This is very, very important. External unbalanced force. What he is saying means, see, this object is at rest, it will remain at rest. The object is moving, it will going on moving till some external force has to act. I have to give a push here, then only it will start moving. Similarly, when the bike is going on, it will be going on till when I applied a brake. So the applying a brake is the force there to stop. Here, push which I given here is the force. There, the help of brake, I start pulling to stop the wheel. So that push or pull is generally a force. So an object will remain in its state of rest or of uniform motion unless it is compelled to change that state by an external unbalanced force. This is called Newton's first law of motion. Third law of motion. Fa is equal to minus Fb. So what is this Fa? It is action. This is reaction. This is Newton's third law. So what is action and what is reaction? It is very simple. Newton's third law says that for every action, there is always an equal but opposite in reaction. For every action, there is always an equal but opposite in reaction. That is Newton's third law. For example, let me say a bird which is pushing the air downward. What is the reaction? The air will push the bird upward. This is downward. The air has been put downward by the action of the bird. Similarly, the air will push the bird upward. This is the upwards. This is called reaction. So for every action, there is always an equal but opposite in reaction. Example number 2, a swimmer who pushes the water backward. This is action, like this. So he pushed the water backward. This is action by the swimmer. The water will push the swimmer towards front. So he pushed the water backward. That is called action. The water will push the swimmer to move front. That is move forward. That is called reaction from the water. So for every action A, that is f of A, there will be a reaction, but it will be equal but opposite in direction. That is very important. Very famous example is that if I have a gun, I trigger the gun. That recoiling, that is a coil which pushes the bullet frontward. That is action. While the bullet releases, it gives a backward force to the gun such that the person will realize the force backward here because it is a reaction from the bullet. So action, reaction, it's common. So for every action, there is always an equal but opposite